Use Newton's method to find all solutions of the equation sine of x is equal to x squared minus 2, correct to 6 decimal places. Remember that Newton's method is based on a recurrence formula that is x sub n is equal to x sub n minus 1 minus f of x sub n minus 1 over f prime of x sub n minus 1. By the way, if I were to put this on an exam, I wouldn't have you probably solve something using Newton's method. That would involve just memorizing the formula, taking one derivative, and then doing a bunch of number crunching with a calculator. Not very efficient, I don't think. What I would ask you to do is derive this formula. Tell me where it comes from. That would be in the first video in this series. Anyway, at this point we need an initial guess. We need f. We have that. Oh, no, we don't. So we're going to say that f of x is equal to the sine of x minus x squared plus 2. I imagine that we subtracted x squared, added 2 to both sides, got this equal to 0, and now I'm looking for a 0 of this function. Of course, it doesn't matter which way we did our subtracting. Then I need f prime of x. So f prime of x is going to be the cosine of x minus 2x. I think you'll find that the calculus in this in the textbook for this section isn't really so bad. Now I know what f is, I know what f prime is, and the thing that we're fleshing out really is x sub n minus 1, f of x sub n minus 1, f prime of x sub n minus 1, and then x sub n, which then becomes my next x sub n, and so on, right? Well, I said we were going to use Excel for this. And in Excel, what I'm going to do is across the top, I'm just going to make notes to myself. So x sub n minus 1, and then f of x sub n minus 1, and then f prime of x sub n minus 1. And I don't know, I'm going to make an initial guess of 0. And then, yeah, I could use the graph, but I'm just going to start with 0. And then for f of x sub n minus 1, I'm now using this. So I need the sine of x minus x squared plus 2. Thankfully, Excel knows trig functions. I'm going to have it do a computation, so I'm going to start with an equals. Sine is a function built into Excel. It needs an argument, so parentheses. And then I'll just click the cell to the left of it, in the parentheses, minus x squared. So click it again, shift 6, 2, so that'll give me x squared, and then plus 2. Now I have a function output. Then I want f prime, which is, for f prime of x, we have cosine of x minus 2x. So, again, Excel knows that the cosine function, so equals, don't forget the equals, cosine of, click on that cell with the 0, minus 2 times that cell with the 0, and then hit enter. And then here, I'm going to write just my note x sub n. And we have the formula in front of us here. And this is where Excel is really pretty nice here, or we're getting there, I should say, equals x sub n minus 1 minus f of x sub n minus 1 divided by f prime of x sub n minus 1, enter. And then, as we said, that output becomes my new input. So this gets just a little bit tricky, but if you know what you're doing, it makes sense. So here I'm going to say this new input equals that previous output. Enter. I don't want to type all this stuff again, but if I take these 3 cells and copy them down, then they'll copy, Excel will copy all of the formulas down, and I now have a new output right here. Now remember, I already said that this input is equal to this previous output. So I can now take these 4 cells and copy them down as far as I want. Once I see that, let's see, 1, 2, 3, 4, 5, 6, right there. I can see that I have 6 decimal places that agree up to this point here. So in my work down here, I'm going to say that x is approximately negative 1.061550. I'm rounding to 6 decimal places. If we want to, we can have Excel actually do the rounding to whatever number of decimal places we want. Let me bring this down a little bit. By just clicking here, and then I'm going to tell it, now it's going to use the 2. It's going to say, I don't have any decimal places, so we're going to increase, oh, my bad. We're going to decrease the number of decimal places until we have 6, and then I don't have to do any like really thinking. Now, if we look at the graph of y equals the sine of x minus x squared plus 2, we can see that there are 2 solutions here. One is negative, oh, here. One is negative, we found that one, and one is positive, and it looks like it's near like 2, but I'm going to go ahead and pick x equals 1. Oh, what we did before, we picked x equals 0, right? Tangent line 0, tangent line 0. So that thing converged. It took 1, 2, 3, really 4 steps before we had the answer there. Now, looking at this graph here, I'll pick x equals 1 as my input. And now this is a really great thing about Excel. It knows all the formulas, and all I have to do is change the first number. And then I can see here we're accurate to 6 decimal places because I already have it giving me only 6. So I can see it matches up to that decimal place. And I can write down the second answer of 1.728466. And I'm not writing squiggly equals because we were told to find solutions correct to 6 decimal places. These are correct to 6 decimal places. Now, notice this took, like, again, so the first iteration, 2, 3, 4. The 5th cell down from here is where I got the answer here. And you saw in the graph that, or I guess you can see here, this x value is closer to 2. So what if I had started with 2? Then it converges really fast. What if I had started with something like 8? It still converges, and it doesn't take too long, right? So Newton's method is pretty efficient for approximating solutions to equations that we can't otherwise necessarily solve.